gold medalist and university topper in ME degree. He graduated BE in Mechanical Engineering from Madurai Kamarajan University in May 1993. Dr. Ilanjanan sir has total teaching and research experience of 28 years in UG and PG level. He guided nearly 21 PhD scholars and his research areas include latest nano materials, nano refrigeration, nano coated solar PV cells, characterization of materials, corrosion engineering, and software supporting technology. At present, he is guiding 6 PhD full-time scholars. Dr. Ilanjanan sir has completed several research projects funded by Government of India agencies and industrial consultancy works. He published nearly 190 papers in reputed international journals and conferences. He delivered nearly 35 expert lectures in various engineering colleges. He got 2 national patents on new aluminum metal matrix composite and nano composite. Dr. Ilanjanan sir has visited several countries. He is a visiting professor to Key Laboratory for Automobile Materials, Ministry of Education, Jilin University, Changchun, China. He worked as a visiting professor in the Department of Mechanical and Industrial Engineering, National University of Science and Technology, College of Engineering, Muscat, Olam for a period of 2.5 years. He received several awards and fellowship. At present, he is holding the additional post of University Placement Officer of PTU and achieved a record placement of 540 offers from nearly 92 top multinational companies in last year. During his period, students are placed in several super dream job offers with a highly salary 42 lakhs per annum, and his service continues in PTU. Now, I kindly request Dr. P. Natarajan, Assistant Professor, Department of MEC, to honor our invited speaker, Dr. R. Ilanjanan sir, Professor and Head of Mechatronics PTU, Mr. Moment. Now I kindly request Dr. R. Ilanjanan sir to take over the session.
Thank you, Mrs. Deepa. Respected Professor and Head Dr. Radharaman sir, coordinator of this today's national level seminar, Dr. Nataraj, esteemed faculty members of Mechanical Engineering Department and my dear students of Manipur Institute of Technology, good afternoon all. Wish you all a very happy Teachers' Day to my here. Once I entered, all your faculty members are familiar to me because most 99% are from our PGU, the former lead. So happy to see a team from our PEC doing wonderful service in MVIT. It's all due to the history we take, the brand value we create, because your professor head, Dr. Radharam sir is my senior and he is product of it. So it continues, and happy to meet you all on the day of Engineers Day. Today it is again a special day for engineers because who are the engineers? Engineers are the one who converts dream into reality. So what we make, what engineers make, we make everything, right? From safety pin to satellite launched recently to Chandrayaan. So only the profession in this world who can make everything from a small pin to satellite, from a house to a architectural building and bridge. It's possible only by engineers. Happy to see you all, the future engineers of our nation, and the responsibility lies on you to take our nation into the next level. And you all know now we are in the world fourth rank of largest economy users in the world. And the present government and the Prime Minister Shri Narendra Modi is trying to bring our nation into the top three position in terms of economy. It means the growth rate is achievable, remarkable. So the contribution from manufacturing sector, industry is predominant. Okay, so as mechanical engineer, robotics engineer, as mechatronics engineer, or automation engineer, the future development of nation lies on your hand. Right? So, as our former President Dr. Abdul Kalam used to say, dream big, okay, and then plan, act to get your dream into reality. That's all. So, what is required to convert your dream into reality? You need passion plus practice, then decide to achieve the goal. So don't allow negativity into your mind or into your thoughts. So always try to keep positive vibrations around you, think positive, then act positive. Okay? So with this few words, so let me get into the topic. Super hydrophobic nanocoating, and my area of research is nanomaterials and nanocoating. And coordinator Dr. Nadraj, he did his PhD in nano-coated solar cells, and he is my proud scholar. So we can get on that. Normally, when we do some research in my research group, we take concept from the nature, and all the PhD work, it will have direct impact on the society. Because in our opinion, engineering is not just transforming the knowledge from books into the human mind. So engineering is the one which makes the common man to enjoy the benefit out of science and technology. So always we take a concept from nature and then use it for engineering application. So when you look around at your home or at your village, or when you walk across the beach, you come across so many natural phenomena. The best example for nanomaterial is algae deposited on the temple tank. கோயில் குளம் இருக்குல்ல, அங்கே மேலே கிரீன் கலரில் வாட்டரில் மிதக்கும், அது பேர் என்ன? பாசி. The particle size of algae, பாசி, is in nanometers. Understand? So, before some 3-4 centuries, the concept of nanotechnology was practically used. Without knowing, they are made up of nanomaterials. There is one church at the UK where the glasses were coated with some material. Okay, so morning when sunlight falls on the glass, okay, they appear in green color. Then at 12 o'clock, at noon, it becomes red. Then evening during sunset, the same glass, it colors in blue. So people wonder, and they thought like, since it is fixed in the dome of the church, something is happening over there. But after the scanning electron microscope, atomic force microscope, scanning probe microscope, which can magnify a particle at 10 power minus 9 meters, people came to know they are coated with nano gold particle. What is the color of gold? Yellow, right? So we call in metallurgy it is not gold, yellow metal. The particle size is 50 microns. Now whatever you are wearing as gold ornament, the particle size is 50 microns. 50 microns means like the thickness of your hair, it's around 60 micron, and the gold particle size is 50 micrometer. When the same gold particle is divided into smaller size, and when it is 50 nanometer, it becomes red in color. When it is 40 nanometer, it becomes blue. 30 nanometers means green color. Because the optical property, it changes with respect to size of the particle. How do we get colors? Due to reflection of light. When light falls on your particle, it gets reflected. So due to the difference in the particle size, when it is smaller and smaller, the reflection takes place at the different directions, then it exhibits a different color. Understand? So this nano material, it was available before 150 years. Without knowing it's made up of nano level. Right? How many of you are final year students here? Just raise your hand. Final year or third year? Okay. If you are planning to do some project in nano related area, like nano material, nano coating, nano applications, you have to keep one thing in mind. Nano scale means 1 to 100 nanometers. Any nanoparticle you want to use should be in the order of 1 to 100 nanometer. It's called a nano scale. Above 100 nanometers, if you use, it will not give the improved property. And below 1, it is not possible. This is one, you can keep it in mind. So what is nano scale? 1 to 100 nanometers. If you want to use nano material in any of engineering application, you can choose between 1 and 100. Second, when particles are in the range of 1 to 20 nanometer, they are in the liquid state. Okay, so when you want to mix in the with a solvent, right? Then what should be the nanoscale and what should be the form of nanomaterial? Liquid. So what is the size? 1 to 20 nanometer means it is in the liquid state. 21 to 100, they are in the powder form, solid state. And most of the literature says particle size of 40 to 50 nanometer gives significant improvement in all the property. So directly you can choose your project, choose a nano material like nano titanium dioxide, silica, alumina, and particle size 40 to 50. Then you coat it or apply, check the property like physical property, mechanical property, tribological property, and you can come to know the property gets improved. You can take up this research. Okay? So here are these two pictures. Can you guess what is it? The first one? Here? Exactly, lotus leaf. How many of you have observed when water droplet falls over the lotus leaf, it will not stick. On the other hand, what happens? It rolls. Right? So when you pour mercury on this flat surface, what happens? It will roll. Like elastic ball, the water droplet, it will not stick. It is called wettability. Wettability is 0 and it will roll. Why it happens? Because the lotus leaf consists of 3 layers of membrane. First is at the nano level, then micron, and then larger in size. So this organic membrane does not allow the water to stick on with the leaf. It is called the hydrophobicity. Phobia means what? Hate. Hydro means water, phobia means hate. So, which hates water, it's called a hydrophobic. The other one again, lotus leaf with a multiple number of water droplets, but they did not stick on. So these are the contents of today's presentation. It's actually a PhD work of one of my scholars. So what are hydrophobic coatings? See, at the end of presentation, whatever doubts you have, you can ask me. And if you are really interested to do some project, you can carefully watch this. It's a research work, but there are a multiple number of avenues to extend this project. So you can take it as your final project. So one of the most notable hydrophobic surface is that of a lotus leaf. The extreme water repellency exhibited by lotus leaf is what inspired scientists to initially pursue research into super hydrophobic phenomena. There are three terms used throughout this presentation. One is hydrophilic, hydrophobic, super hydrophobic. It's all with respect to the contact angle between the solid surface and the liquid. So hydrophobic coatings are specialized materials that repel water and other liquid. What is the key purpose? To keep surfaces dry, clean and resistant to water damage. The previous one is hydrophobic and this current slide is on super hydrophobic surface. So what is super hydrophobic surface? So when the contact angle is less than 90 degrees, it is called hydrophilic. You take a drop of water on your finger, then place it on the surface, maybe on the center of your palm. And when you draw a tangent across the interface of liquid and the surface, it's called a contact angle theta. If contact angle theta is less than 90 degrees, it is called a hydrophilic. It means it loves. When it is above 90 degree up to 149 degree, it is called a hydrophobic. If contact angle is beyond 150 degree, it is called a super hydrophobic. That's all. So depending upon the application, we can make this contact angle. Okay. So it's called wettability of the surface. Here you can see hydrophilic where the contact angle is less than 90 degree. For hydrophobic, it is above 90 degree, but below 150. When contact angle is above 150 degree, it is called super hydrophobic. And what is contact angle? The wettability of surface is defined as the tendency of fluid to spread or adhere to the surface. In order to access surface wettability, the angle formed between liquid gas interface and surface due to surface tension forces evaluated, and this contact angle is called theta. So based on contact angle, surfaces can be classified as hydrophilic, hydrophobic and super hydrophobic. Okay. How hydrophobic coating works? This is the mechanism behind hydrophobic coating. So in future, you are going to get waterless washing machine. So at each home, we have washing machine, right? And what would be the approximate consumption of water for each drying? Each time when you switch on the water washing machine, how much water is consumed for one complete processing? Approximately வீட்டில் வாஷிங் மிஷின் யூஸ் பண்ணி பார்த்துருக்கீங்களா? எவ்வளோ வாட்டர் கன்சூம் பண்ணணும்? சே ஒரு 6 liters கெப்பாசிட்டி, 6 kg கெப்பாசிட்டி வாஷிங் மிஷின் எவ்வளோ? 10, 50, 100, 200. ஒரு 6.5 kg capacity washing machine, it will take 200 liters of water. Right? So it means if you have a 500 liter water tank, it will take half of consume half of the water tank. But the research is going on to design and develop waterless washing machine. The consumption of water will be only 5 to 10 liters. So you can save lots of water. Here in India it is fine. You get plenty of water resources. But think about Middle East. There are not even a single river. One side mountain with rock, other side Arabian Sea. That's all. Even for drinking purpose, they convert seawater into drinking water by desalination process. Okay? Take Israel. Not even a single water resources available, natural resources available. So they are forced to develop waterless washing machine, and for this kind of waterless washing machine, this hydrophobic mechanism is used. So how hydrophobic coating works? Based on the molecular structure and under contact angle. Molecular structure means hydrophobic coatings have unique molecular structure that minimizes interaction with the water molecule. The intermolecular force of attraction between water molecule is minimum. It's called the surface tension. Similarly, the contact angle, they create high contact angle causing water to beat up and roll on the surface. The first one is hydrophilic surface, where contact angle is minimum, say 10 degrees, 15 degrees. So it sticks down to the surface. On the other hand, when contact angle is above 150 degrees, it just roll over. And this mechanism is used in waterless washing machine. Can extreme heat cause your auto gas to break? Have you ever seen, or when you park your car under sunlight for one day, complete day, during hot summer, have you come across the windshield crack? Or cracks on the headlamp? How many of you have cars? Raise your hand. Car. Okay, or at least two-wheeler. Everybody would have got a two-wheeler, right? So when you purchase a two-wheeler from the showroom, the headlamp, it looks bright, right? After like 2 years, so what will be the color of headlamp shield? It becomes dull. And when you park it under sunlight, you can find so many minor cracks. The reason is the UV rays from sunlight, it reacts with the polymer. It is made up of polymer. The headlamp is made up of polymer, and they loses their ductility. So it becomes brittle and the crack it initiates. Similarly, when you park under extreme heat means above 50 degrees Celsius, the windshield it gets broken. In many cars you can find this kind of windshield crack. This is due to the extreme heat. Second one. So when you park for months together, this will happen. The windshield will become brittle, and like sugar candy. Sugar candy means in Tamil what you call kalkand. So it will break into pieces like sugar candy. Okay? The reason is due to the penetration of UV rays through the windshield, and the windshield is made up of what? Material. Glass term. Raw material in that. Silica. What do you get silica? River sand, beach sand. It's called silica. So silica is processed to get windshield. Understand? So at high temperature, the silica loses its mechanical property and physical property, becomes brittle, and then it breaks. So when you happen to travel across Middle East, near desert, you will find this signboard. Stop extreme heat danger. Because your body, the water is sucked by sun rays, and you will become dehydrated and then get fainted. So government, they give leave to the construction workers, when the temperature crosses 50 degrees Celsius, automatically they get leave. And it happens during May, June, 2 months. The other side, when extreme cold temperatures break car windows and windshield, yes. This is one. Like in India, Himachal Pradesh, Jammu and Kashmir, Ladakh, the northeast part, this is a common problem. Due to the extreme cold temperature, ice deposits over the vehicle and then it breaks the windshield. The other windshield. So here there is snowfall, very high extreme snowfall. So the first one is extreme hot, second one extreme cold, third one. How many of you have driven your car during heavy rain or fog? When you drive two-wheeler in rain, what are the common problems you face? Kind of visibility, poor visibility. Opposite Pondicherry, Modigo. So third, when you apply brake, what happens? It becomes slippery road. Because rainwater will act as a lubricant, so the sliding velocity becomes more when you apply brake and it will hit. Right? This is the third problem. Even when you use wiper and you drive the car at extreme height during rainfall, it is difficult to view the road. This is, here wiper is on, but the road visibility is very poor. Okay. So, based on these three common issues, we have taken up this research work. So, we developed a coating, hydrophobic coating, which gives solutions to extreme hot temperature, cold temperature, and during heavy rainfall or fog season. So any project you do, it should have some practical applications and it should have impact on the society. Understand? So this research is mainly focused on experimental study of windshield glass. The use of these laminated glasses are now globally playing a vital role in aircraft, automotive and marine industry and also used for various conceptual and commercial purposes. Presently, automotive industries are facing a lot of problems related to this type of glass. Significant issue is that windshield glass in cars are encountering a lot of minor cracks and contract when it is exposed to extreme hot or cold conditions. So Gulf countries such as Kuwait, Oman, Saudi, UAE, Qatar, Bahrain are the major ones that experience this kind of failures. We cannot withstand high temperature like 129.2 degrees Fahrenheit or 54 degrees Celsius. Material begin to lose its ductility and other mechanical properties, then total failure of windshield happens. It is not only the factor that causes this kind of failure, but in contrast to snow, fog, mist has been a day-to-day problem in most of European countries and also in India. When the temperature is below 32 degrees Fahrenheit. 32 means how much degrees Celsius? 32 degrees Fahrenheit equal to 0 degrees Celsius. So when the temperature is below 0 degrees, this happens. So to overcome this failure, windshield glasses were coated by solvent process with two different nanofillers such as nano alumina and nano silica. Two types of filler were chosen. One is nano alumina. Alumina is always known as aluminum dioxide. Silica is silicon dioxide. So these two nano fillers were added when the windshield glass was manufactured. So a glass piece of 40 by 20 by 10 samples were put, nano fillers were added to salt gel, isotope means zinc oxide, then TUO is tetraethyl orthosilicate, which is a solvent. Then MT is methyl trioxoxysilate, with varying weight percentage. These were coated on the glass, windshield glass, by tip coating and spray coating method. Then they were characterized using same XRD tags, and different tests such as UV test, water contact and test were measured, and finally anti-fogging test was conducted on the coated and uncoated sample. So this is a structure of PEOS and the other one is MTES. So what is the effect of hydrophobicity? So this is how the salt gel, you have to synthesis, it won't be available in the market. So you have to buy the solution, make it a solvent, then add nanofiller, then apply the coating. So we tried with the true nanofiller, you can choose a different nanofiller, like the silver oxide or titanium dioxide. Okay, silica. Silica is already used, aluminum is used, other than these two nanofiller. If you use different nanofiller, then it is again a new BTEC work, MTEC work, PhD. So here, salt gel derived coatings have been found to be useful for several applications due to ease of solution-based processing, and see, salt gel process everybody can do in the lab. It's a very simple process. By chemical reaction takes place. So the research is focused on four objectives. One is to synthesis. Synthesis means preparing. It's a technical term used in research. Synthesis means preparing salt gel and coat on the glass surface which can form hydrophobic effect. Then analyze hydrophobicity of synthesis with glass with water contact angle, which can lead to prevent wetting during rainfall, snow, mist. Then structurally characterize the newly synthesis in glass. Then investigate the samples for UV penetration and anti-fogging test. So this is the methodology. First you need to decide what type of test are you planning to do, or which methodology will be useful. So if you arrive at methodology, that's all. You can do complete experiment one by one. Finally, you can arrive at conclusion. So you have to procure the material, synthesis in new glass windshield. Then to prevent the wetting during rainfall, snow, mist, you have to apply a coating by nano aluminum, nano silica, and by using surface roughness test, thermal analysis, tags, water contact angle measurement, hydrophobic anti-fog test, you can conduct various experiments to prove the coating development is successful. Okay. Then investigate the hydrophobic effect, characterize the material, then come to a conclusion. You can compare among the different tests. These are the properties, physical properties and chemical properties of the nanomaterial chosen. Silica first one, alumina, zinc oxide, PEOS and MVIT. Have you used zinc oxide anywhere in your day-to-day life? Zinc oxide. How many of you use Fair and Lovely, Fair? Right? So the Fair and Lovely, Fair, everybody use, right? For the boys, what is the brand? Fair and Handsome. Right? The composition of all these Fair and Lovely, Fair and Handsome, it consists of zinc oxide. The zinc oxide does not allow UV rays to penetrate the skin. When you apply a layer of sun preventive film, it's called the SPF. It makes UV rays to gets reflected instead of it penetrates through your skin and then makes the complexion dull. So every day you are using zinc oxide and we use it for research purposes. Similarly, silica, alumina, they have different applications. So these are the sample preparations. And the module one is preparing zinc oxide salt gel formation. Like you need, these are all the chemicals used. You need to buy zinc acetate dihydrate, 15 ml, add it to the distilled water, then use sodium hydroxide 8 grams, mix it, then pour the solution 2 into solution 1, titrate it, then add nano into it. Finally, you get the solvent which can be coated over the material. That's all. It's a simple process. These are the chemicals used, distilled water, ethanol, acetone. First, you need to clean the glass. Then this is dissolving the solvent into the chemical like NaOH, zinc oxide. Then when you stir it continuously in magnetic stirrer, the liquid is converted into gel form. Right, so here you can see formation of gel. And now you can apply the solvent we have prepared by using the coating process. Just liquid and then take it away. You will get uniform coating over the glass. So dip coating is done. The sample sizes are very small because you need to do lots of experiments. So for research purpose, we divide the windshield into small samples of 40 by 30 millimeters, something like that. Then you have to do the calcination. This is to keep the solvent attached with the windshield. It should not come out at any extreme hot temperature or cold temperature. So always you have to do some kind of heat treatment. So this is called the calcination. And after you coat zinc oxide over the glass windshield, you can measure the contact angle. It's called the wettability. Okay? And by using tensiometer, you can measure the contact angle. A water droplet will be dropped from the tip of the syringe needle, and a high-speed camera, 50 frames per second. In 1 second, it will take 50 frames. And from that frames, you can measure the average contact angle. So here you can see for zinc oxide, nano alumina, nano silica, the different contact angle. Right. So after the experiments were conducted, this nano zinc oxide, nano alumina, and nano silica were infused into the windshield glass. So we went to the glass manufacturing, windshield manufacturing company, and then during the manufacturing process, all these research findings were introduced. And this is the glass manufacturing company. They prepare windshield for all popular brands in India, for Maruti, for Hyundai, for Tata Motors. So during the manufacturing process, these nano additives were added, mixed with the raw material, and the glass sheets were prepared. Okay. Then test were carried out. UV penetration. This helps to find out whether the UV rays are stopped by the coating prepared. And among the 3 different nano additives, each one gives better result. Okay, so in the UV penetration, you will calculate 3 properties. One is absorption, reflection, transmittance of UV rays. XRD means X-ray diffraction technique. X-ray diffraction technique is a characterization technique which tells you the presence of silica and alumina on the coated sample. Okay, it's a confirmation test. And after UV penetration test was conducted, so these are the results, like absorption is improved by 23%, reflection 28%, and transmittance 21%. Then for alumina, it is 23, 57, and see for alumina reflection is more compared to zinc oxide. Then we combine silica plus alumina, and the reflection is 37%. So this is a comparison among the 3 different nano materials, such as alumina, silica separately, combination of silica and alumina, with respect to transmittance, reflection, and absorption. Then this is the result for zinc oxide coated sample. So zinc oxide coating with nano alumina fillet tended to form hydrophilic effect. It means it attracts water. Then silica and pure zinc coating. Higher the thickness of the coating creates more effect on the glass. Transparency is partially excluding zinc oxide coating. It means raw zinc oxide coating does not influence our property. So we need to try with different material. So the next one is this TUI solvent was taken, then it was mixed with the nano alumina, nano silica, then experiments were carried out. So So here coating of salt gel on the sample. Then again hydrophobic effect was calculated by measuring the contact angle. See here you can see the water contact angle is better. It means it is more than zirconia. So this is the contact angle measuring instrument. It is called the tensiometer. So it captures the image. The camera captures the image, and it will be displayed on the monitor. And we can take all the frames, and the software will calculate and then give you the average contact angle value. So this is the contact angle measurement center. Right. So here you can see for one frame, the contact angle is 93.75 degrees for only TUI. When nano alumina at 1.5% was added, the contact angle is 108. When nano silica was added, the contact angle became 130 degrees. So all these are in the range of hydrophobic effect. So on the other hand, when nano silica 1.5% was coated, they exhibit 153.42. It means, what is this effect? Super hydrophobic effect. Is achieved with the help of nano silica. Then module 3 was spray coating method, where by spray coating technique you can apply the same nano silica, nano alumina over the windshield, and you can do repeat that. Stage 1 is like you need to add ammonium hydroxide with ethanol, then EOS with ethanol, then stage 4, stage 5, stage. Finally, you prepare the solvent, and this is how you need to apply the spray coating technique. Okay. Pressure, operating pressure, you need to maintain at 40 to 60. Tank capacity, nozzle, etc. You can directly apply. This is the cheapest method. And you can coat on any dimension of the windshield. Okay. So the spray distance was optimized, pressure was optimized, and then later on the sample they were coated. So again it was heat treated. Then the test result shows like compared to the raw solvent like EOS, MTES, the combination gives better result. And EDAX means energy dispersion analysis of X-ray, where the backscattered secondary electron helps to identify what is the percentage of each element present on the coating. Okay, it's called a characterization technique, and it will tell you what is the percentage of silica, alumina, etc. These are all record for a PhD. And this is the EDAX sample for 2, and here you can magnify up to 25,000 times. What is the normal magnification of microscope? 500, 1000, 1500 maximum. But under scanning electron microscope, you can magnify a particle up to 35,000 times more. The same sample can be magnified at 1.2 lakh times under transmission electron microscope. These are all very expensive equipment which cost minimum 1 crore. So these are the test results for nano silica and EDAX. They are showing like the presence of different elements. Silica is okay. So here alumina was added 1.5%, 2%, 2.5%, 3 different weight percentages, and the samples were examined. And this shows the UV penetration test results from spray coating method. So absorption is maximum for the sample number 8, and transmitted is almost wavelength remains same, and reflection it varies from 0.43 to 2.7. This is the result with respect to alumina, silica, and TEOS and MTES. Here different contact angles for solvent TEOS and and this is the proof for contact angle. Right, so here in dip coating, we use two types of coating, three types of coating techniques. One is dip, spray. Coating is difficult to get uniform coating, and the surface finish varies with respect to the coating process. On the other hand, spray coating produces uniform coating, surface finish is higher. So spray coating technique is cheaper, plus it gives improved results than dip coating. And these are the water contact angles for dip coating versus spray coating. So now you need to the hydrophobic effect. We said no. In order to prevent the breaking of windshield from heat, cold, and then during rainwater, the hydrophobic effect is required. So this water falling method test was carried out. So what you have to do is, the coated sample, you apply iron oxide powder. What is iron oxide in colloquial language? Rust. So you need to apply rust over the coated sample, then pour water. Keep the sample at 35 degrees and then pour the water. So when it carries away very little amount of iron oxide powder, then hydrophobicity is very high. This is the confirmation test for hydrophobic as per ASTM. So here you can see the amount of iron oxide removed by the water. It was minimum for SiO2 at 2% compared to the other percentages. So hydrophobicity is high for samples coated with nano silica 2%. Then this is between uncoated and the coated sample. Here again you can see for SiO2 at 2%, minimum amount of the iron oxide powder was removed. Then anti-fog test, the simple anti-fog test as per ASTM is, keep the coated sample above the glass beaker, then keep the water to 100 degrees Celsius. What happens? Water is converted to vapor, then deposits over the coated sample. And then you measure the anti-fog capacity. Here you can see. One is without coating, another is with the hydrophobic coating. There are no presence of water droplet, right? At sample 1, sample 3. Then at sample 5, SiO2 with the 2%, there are no water droplets. It means what? When you apply the coating, the developed by this research, during rainy season, no water droplet. It will stick onto the windshield. So you will get very clear vision and you can drive the car. One advantage. Second advantage is during winter season, when there is fog or mist formed over the vehicle, it will not stick up. So it will float because of hydrophobic nature. So these are the anti-fog test results. Coating thickness of different samples. These are all the measurement of RE, average surface roughness. By using surface roughness scale, you can directly measure the coating surface roughness. And this is a conclusion. Coming to the conclusion of the entire research work. Samples were investigated for UV penetration. Their absorption, reflection, and transmittance was examined. And high absorption was achieved for 2.58% of alumina at 310 nanometers wavelength. Then high transmitting rate of 9.7% of wavelength at 370 nanometers was achieved by 2.58% of silica. And the coating thickness of samples were calculated. Minimum is 64 micron. Surface roughness is lower for high contact angle. The hydrophobic surface test analysis was conducted, and all 9 coated samples achieved property of removing dirt from the surface with the high contact angle of 153 degrees Celsius. It means by using nano silica 2% by 8%, we achieved super hydrophobic effect. Then spray coating method can successfully prevent fog, mist, and avoid accident due to poor vision in the windshield glass. And it finds wide application in automobile engineering and commercial fields. These are the applications of hydrophobic coating. So now during winter season, and there is a fog, mist, etc. When you wear the helmet, it is difficult to view the road. You will get poor vision. When you apply a simple hydrophobic spray over the helmet, you will get a clear vision. You can see without anti-fog coating and with anti-fog coating. Similarly, on the windshield, just by spraying this hydrophobic coating, that you can come out of this issues due to heat, cold, and temperature, etc. So you can coat on the windshield, side glass, rear view mirror. Then again on the solar panel. Now we are trying to take up project research on self-cleaning of solar water panel. If somebody is interested, you can join. Why we have taken up this research on self-cleaning of solar panel is, there is a place near Ramnath, where the Adani, they have installed Asia's largest solar power plant. Do you know about it? The place is called Airwadi. Near Ramnath, near Ramnath. Adani power plant, they have erected 650 megawatt solar power project. It means nearly 10 lakh solar PV panels are erected over there, maybe around 800 acres area. So due to the geographical nature of that place, since it is nearer to Rameshwaram, so you get wind throughout the year, from during northeast monsoon and northeast and the southwest, both the monsoons, the salt and the sand particles are carried away by the wind, atmospheric air, and then they deposit over the solar panel. What happens when solar PV panels are covered with sand? What happens to the efficiency? It gets reduced. Right? Instead of 650 megawatts, the maximum capacity, it is reduced to 450, 500 megawatts. Do you know how they clean the solar panels which are covered with the sand? They use water, drinking water. They bring it in a tanker, manually they spray and then clean the solar panel. So per day, some 10 million liters of water is wasted in Ramnath district. So instead of you waste the natural water, we apply the hydrophobic coating. You can apply self-cleaning coating. So the self-cleaning coating, it will not allow the dust, dirt to deposit over the solar PV cells. It will clean automatically. Okay? And it will be very much useful. Hydrophobic effect on the panel, not reflectability coating on solar panel. And these are the other applications in automobile. Hydrophobic coatings are used on windshield, side mirror to repel rain and make cleaning easier. Electronics, protect the electronic devices from water damage. So when you have an expensive mobile like iPhone or Samsung, and when you drop it in water, accidentally, what happens? It will damage. The display immediately goes up. And to change the display will cost 5,000 to 30,000 rupees. When you coat with the hydrophobic coating, nothing will take place. It will prevent the damage. Textiles, used in clothing to make fabrics water resistant. So today to clean our cloth we use water. But the future textiles, they are going to carry fabrics which are water resistant. No water is required for cleaning our cloth. For architecture, applied to building exterior to prevent water damage and staining. And this is what I said. During the beginning of presentation, I said about what? Waterless washing machine. Instead of Surf Excel or Ariel liquid soap, this detergent powder, they use polymer based granules which are hydrophobic in nature, and they remove the dirt, grease, dust, etc. from the clocks. So this is the future of the washing machine. Waterless washing machine. So these are the references. Thank you very much. So hope you understand three terms: hydrophobic, super hydrophobic, then lotus effect. Right? Then about engineering application, the future of washing machine is waterless. And where can you use hydrophobic coating? On the automobile windshield, side mirror, rear view mirror, on the electronics, mobile phone, textiles, on the fabrics, right? And in the architecture, you can use exterior, interior paints. So it has lots of potential applications in several fields of engineering. So you can take up a little piece of work and do it as your BTech project. And I am ready to help. Okay. If you have any doubts, you can ask me.
Any queries?
Control parameters, input parameter, like we use dip coating and spray coating technique. So for dip coating, you need to first optimize the spinning speed. Then the distance between the droplet of the solvent and the sample. These are the two parameters for dip coating. For spray coating, you have to optimize the pressure, the spray gun distance between the spraying machine and the sample, and the concentration of solvent. These are the three parameters. So based on the three parameters, you will get the record output. So this has to be usually optimized. Nozzle, it's a solvent. So it will open. Any questions from audience?
Any questions from audience? Girls?
Can you apply hydrophobic coating on your face so you will not get sweating? Your backup will not get damaged. Morning, whatever you apply, then you will go back to home, you will be retained.
Thank you, sir. A special thanks to Dr. R. Puducherry, sir, Professor, Head of Mechatronics Engineering at Pondicherry Technological University. He will enlighten us on super hydrophobic nano composite coating, synthesis and application. Your expertise in this field was truly remarkable, sir.
Thank you.
நாள் நம்ம கிளாஸில் நீ தான் சர்டிஃபிகேட் என்ன சர்டிஃபிகேட் பார்ட்டிசிபேட்
Good afternoon, sir. Now I welcome our beloved principal, sir, and Dr. R. Evangeline, sir, for this valuable session. Now I kindly request our beloved principal, sir, to honor today's chairperson, Dr. R. Evangeline, sir, by giving certificate of appreciation. Thank you, sir. Now I request Dr. P. Natarajan, Assistant Professor, Department of Mechanical Engineering, to summarize the seminar.
Respected principal of these institutions, HODs of various departments, faculty members, and my dear students, a very good evening to one and all. Today we gathered here to celebrate a significant academic event, that is 2 days all-India seminar on advances in nanotechnology for sustainable development. This seminar has been sponsored by one of the most prestigious forum in our country, the Institution of Engineers, India, Puducherry State Center. It takes place on September 4 and 5, 2023 under the aegis of Mechanical Engineering Division Board, IEA, in association with Department of Mechanical Engineering at Pondicherry Institute of Technology. So our seminar has been graced with the presence of eminent speakers who have shared their invaluable insights with us. One of the first today, we were honored to have 2 keynote addresses by Dr. S. Mohan, Vice Chancellor of Puducherry Technological University, as a chief guest, and we were privileged to hear another keynote address from Dr. N. T. Rangareddy in afternoon session. Dr. N. Sivasubramanian, a senior scientist and former chief guest, general manager at ISRO, Trivandrum, for delivered an inviting lectures. On the second day, we have 2 distinguished speakers, that is Dr. P. Elumalai, a professor in the Department of Clean Energy Technology at Pondicherry University, and Dr. R. Evangeline, professor and head of the Department of Electronics at Puducherry Technology University, graced us with their expertise. We are delighted to inform you that we have received 250 participants in this seminar. As per the IEA guidelines, 10 papers were presented, while the remaining papers were presented in the form of posters. So we encourage the participant with the award of certificate as well as the cash prizes for a total of rupees 1,000 in total. 5,000 in total. The first prize winner will receive 1,500. The second prize winner will receive 1,000, and the third prize winner will receive 750. Additionally, we have the complimentary prizes of 300 for 5 deserving participants. So I extend my heartfelt gratitude to the IE members, the management, our respective principal, the head of the department, and the faculty members for this support. A special thanks to the chairman of IE Puducherry State Center and our beloved head of the department, Professor Dr. B. Rajaram sir, for the guidance and support for making the event a grand success. Last but not least, I like to say a special thanks to their dedicated colleagues and students, volunteers for your commitments and collaborative spirit made the event a memorable one. Thank you, one and all. Thank you.
Now I kindly request Dr. B. Rajaram, Chairman of IEI, Puducherry State Center, to deliver the welcome address.
Good evening. Respected speakers of today's valedictory program, Dr. R. Evangeline, invited speaker from Puducherry Technological University, Professor and Head, Department of Mechatronics Department, respected principal, fellow departments, faculty members, and beloved participants. Today I come to the 8th session, the valedictory program of the 2 days All India seminar on advances in nanotechnology for sustainable development. Whereas, as our faculty Dr. Natarajan mentioned, these 2 days are fully knowledge-packed event with a lot of resource persons from different parts of the country sharing their expertise and their knowledge. Of course, for our MIT, this is the first kind of program. So in the history of MIT, we conducted all the seminar for the first time last month, namely by the IoT department with Dr. Rajeshmi and Dr. Puducherry. And this month, we are again the second program. Within a frame of around 10 days, we are getting permission for conducting the second program through IE itself by mechanical department. And as I told you already, the third program is the next month on metallurgy and material science. So different divisions are giving permissions for our department and the college for conducting a lot of programs based upon our performance. So we attended the programs of various speakers. In fact, the first session itself is a very marvelous one by Honorable Vice Chancellor of PTU. We invited him only as the chief guest, but out of his enthusiasm, Sir has come forward to deliver a talk on the topic in nanoscience and sustainable development. We are very much impressed upon his lecture, followed by Dr. S. Reddy. And in the afternoon, one of the eminent scientists involved in Chandrayaan shared the platform here. It's very, very difficult to get such a resource person, but out of our contact, we brought him here, and in spite of his hectic schedule, he was here for about half an hour, half a day, and we were able to get a lot of information from him. The one thing is the binocular what he has mentioned. Anybody remember that? One technology has mentioned. The binocular. So just pulse and get the speeches done around 1 kilometer away. So it's one of the new concept which is totally not heard by anybody. Of course, before 40 years, several Hindi movies come. The Sholay, Babila, the Param, and movie was Sean. I remember exactly. The movie of the hero is on the binocular path, particularly a villain arpan. Our passes the virtue for about half kilometer. Binocular path, villain passes the mouth movement of virtue of the long. There have been fiction on the path. But today, what has done in the movie has come true. And the TV is Hindi padam, Telugu movie but the movie is the scene. Just to give you all of people laughed at that scene. But today, what Sir told yesterday is a fact. So by means of nanotechnology, we are able to get the speeches made by the opponents in the other area, maybe Pakistan area, by means of the binocular with the nanotechnology. It's one of the new concepts what we have gathered yesterday. Second thing is the launching of Chandrayaan on 23rd. In fact, there are several contributions that are made by scientists, places and all. Pondicherry also has a small role in that one. That I was talking to the principal also. There is one company called General Office Asia at Dollar.com. They are a very, very confidential and secret company supplying equipment for military alone. So their component is used in the Chandrayaan. So in Chandrayaan, we have the component from Pondicherry also, maybe a small fiber optic lens. These are highly sensitive equipments manufactured confidentially. So Pondicherry also played a very important role in this particular Chandrayaan project, as our guest told last week I was in Madurai. While addressing and discussing, he was telling this talk. In Pondicherry also there is a company, they are supplying for our ISRO by means of their technology. So we cannot be aware of what is going on around us, but the entire world knows where is the technology and where is the potential. Similarly, the speakers gave very good talk for the past 2 days. And also, I wish to mention that our institution is famous for conducting a lot of this type of Erasmus programs. In fact, last year in history, when I was the president, we hosted Puducherry. And I am very happy hosting that in our institution itself. This year, as chairman of Puducherry State Center, again we are hosting the first kind of program, mainly the Orange Seminar. 1, 2, and 3. 3 years are being held in the consecutive 3 months. So with this few notes, I wish to welcome the chief guest of today's program, Dr. R. Eminent, who has accepted our request and come for delivering a lecture and sharing his time for the valued session also and giving the prizes. In fact, we are giving the prizes for the best papers also. So most welcome, sir, on behalf of MIT and IEA Puducherry State Center. Welcome. Fellow principal, who is again all the programs, the motivating force, for coming out to this valued session. Most welcome, sir. I welcome all the dignitaries available here at our department. faculty members, and participants. The program will be followed by prize distribution and feedback sessions. Thank you very much.
Thank you, sir. I request our principal sir to share a few words.
Respected Chief Guest of Validity Function of today's seminar, Professor Rajaram, other heads of departments, faculty members, participants from other institutions, and your students. Very good evening, all of you. I'm joining with a team of Institution of Engineers of our MVIT student chapter in welcoming the respected guest of the validity function. Yesterday and also today you had many sessions on which the experts have given a lot of inputs to all of you on the advancements in nanotechnology and how the nanotechnology is supporting the people for sustainable development. As I told you in the yesterday's inaugural function, nanotechnology is an emerging field. It finds almost in all areas it has got applications. Particularly in the medicine, it has got a wide range of applications. In other areas also it has got different applications. So whatever inputs that you have gathered through the experts who delivered lectures on various topics related with this, you take forward and go in depth on the topics, and you see what are all the possibilities on which you can apply the knowledge that you have gained through this program. So as far as our college, in all the associations and also the professional body student chapters, we frequently conduct a lot of programs like this for the benefit of the students. Through all these programs, our students are getting knowledge on latest developments on technology. So only thing that you need to do is, see, you should not think that we are getting some inputs and with that we are forgetting it. It's not like that. Whatever the things that you have gained, knowledge you have gained, you go in depth and try to develop, try to apply it and try to develop new products related with it, so that you will have more idea about it, so that you can create innovative products. You can develop innovative products which will find some applications on social aspects. So with this request, I once again welcome our guest and also thank you, sir, for having spent your valuable time with all the students by the way of giving a lot of inputs on this topic. Hope all of you have a very 2 days at our institution. Keep on working on it because we know that technology is fast. We have to move in pace with that. So each and every day new technology is coming up. First you should understand, then you should apply your mind to know more about it, and you should try to develop some innovative products. So with this, once again I thank, I wish all of you the very best. Have a nice day. Thank you very much.
Thank you, sir. Now it's time for distribution. The prize winners of the paper presentation are: first place, Mr. S. Vishnu from Mechanical Department, PTU. Sanjay S.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
ஸ்டாப் பண்ணி வச்சுருக்கேன். ஓகே,
1 hour 46 minutes.
இந்த லிங்க் எல்லாத்தையுமே வாங்கி வச்சுக்கங்க.
இவரு நானும் பிரசன்ட் பண்றது